Hello guys, welcome back. PK here. So in this video, we're going to be solving this interesting algebra question from National Math Olympiad. So the question is, find a triple of rational numbers a, b, and c such that cube root of the 2 minus 1 is equal to cube root of a plus cube root of b plus cube root of c, right? So for this question, just to make it a little easier to work with, I'll be making a little conversion, right? So I'll be calling this entire left-hand side as the x. So calling x as cube root of 2 minus 1. Then again, I'll be making up another variable, that is y. I'll be calling this as just the cube root of 2, which means now your y cube is equal to 2. Okay, so from this first one, x is equal to cube root 2 minus 1. That means your x cube is then equal to the cube root of 2 minus 1, that is y minus 1, right? Okay, so this is an important condition for us to use. Okay, then going back to this, right? Going back to this y cube is equal to 2. If you subtract 1 from the left and right hand side, then it's going to be y cube minus 1 is equal to 1, right? But then again, the left hand side, we can easily factor this out. So if you factor your left hand side out, then this is now y minus 1 times y squared plus y plus 1. That is equal to 1, right? Which means your y minus 1 is equal to 1 over y squared plus y plus 1. But then again, let's talk about this denominator. Let's talk about this denominator, y squared plus y plus 1. Using this, y cubed is equal to 2, right? So y squared plus y plus 1. This eventually should be equal to then y plus 1 cubed over 3. We'll be checking this y. Because now if you work on this y squared plus y plus 1, we can easily rewrite this as now 3y squared plus 3y plus 3 over 3, right? But then again, 3 is now 2 plus 1. So we can rewrite this right-hand side as 3y squared plus 3y plus 2 plus 1 over 3. But then again, we already have this y cubed is equal to 2. So that's why 2. We can replace this y cubed. That's why your numerator is y cubed plus 3y squared plus 3y plus 1, which is y plus 1 cubed. So that is why y squared plus y plus 1 is now going to be equal to y plus 1 cubed over 3. So that's why now we can plug this y plus 1 cubed over 3 to this denominator, right? And at the same time, x cubed is equal to y minus 1. So we are now working on x cubed is equal to y minus 1. That is equal to 1 over y squared plus y plus 1. That should be then equal to just reciprocal of this, right? Which is 3 over y plus 1 cubed. So that's why from this, we can represent your x as cube root of 3 over y plus 1. Now, going back to this y cubed is equal to 2. Now, at this time, we can add 1 to both sides, right? Then we'll be working on y cubed plus 1 is now equal to 3, which means the right-hand side is y plus 1 times y squared minus y plus 1. That is equal to 3. Okay. So that is why now 1 over y plus 1 is what we're interested in eventually, right? Because y plus 1 is on the denominator. So that says your 1 over y plus 1. This is going to be equal to y squared minus y plus 1 over 3. Okay, now using this, right? 1 over y plus 1 is equal to y squared minus y plus 1 over 3. So we can rewrite the expression for the x, right? So x is then going to be equal to now cube root 3 and times y squared minus y plus 1 over 3. Okay. Take a look at this. We have y squared. But then again, we already have this y is cube root of 2. So knowing how your y is cube root of 2. And then that means y squared is cube root of 2 squared, which is cube root of 4, right? So we can plug this into the y to talk about the value of the x, which is the whole left-hand side of your equation based on our conversion, right? So that's why let's now talk about the value of the x. So that's why if you plug it in, then your x is going to be equal to, okay, cube root of 3 over 3. This is going to be cube root of 3 over 9 inside, right? So that's why it is cube root of 1 over 9. And then parenthesis, y squared, that is cube root of 4, right? So cube root of 4, then minus y, that is cube root of 2. Then we have plus 1. It's all about distributing this cube root of 1 over 9 to those 3 terms inside of your parentheses. So that's why, if you work this out, then it has to be cube root of 4 over 9. And then we have plus cube root of negative 2 over 9. And then plus cube root of 1 over 9. We push this negative sign back into your radical because we have cube root of a plus cube root of b plus cube root of c, right? So that's why we already got an answer. Your a, b, and c is now 4 over 9, negative 2 over 9, and 1 over 9. That is the final answer for this question. Okay, so pretty interesting algebra question from National Math Olympiad. So I'll be back with more videos, more questions like this sometime soon.